For what value of x is 4x minus 8 plus 3x equal to 12x plus 5? We have 2x equal to 20, and therefore x will be equal to 10. What is the value of 3.5 times 2.5 plus 6.5 times 2.5? We can factor out a 2.5, and when we do, we get 3.5 plus 6.5, and 2.5 times this. This in the brackets is 10, I believe, so that would be 25. Ada is younger than Darwin. Max is younger than Greta. James is older than Darwin. Max and James are the same age. Which of the five is oldest? Ada is younger than Darwin. Okay, so there you go. Max is younger than Greta. James is older than Darwin, so put James here, and let's put a greater than sign. Well, actually less than sign, whatever. And then what's next? James and Max are the same age, so Max can go here. We put a little comma there since they're the same age. And then I guess that means both James and Max are less than Greta. Who is the oldest? Well, according to this inequality, the oldest is G, which is Greta. Determine the average of 1/2, 1/4, 1/8. All right, so 1/2 plus 1/4 plus 1/8 divided by 3. And that would be, let's see here, 2, 2, 4, 4. So 4 plus 2 plus 1 is 7 over 8, all over 3. So 7 over 8, invert and multiply, and that would be 7 over 24. Suppose that m and n equal to those things. What is the value of m plus n? All right, so I'm going to do this a little carefully here because I don't want to mess this up. So 1 to the power of 5 plus 2 to the power of 4 times 3 to the power of 3. I'm going to put that in brackets. Minus 4 squared divided by 5. I'm going to put that in brackets. And then the n is very similar. 1 to the power of 5 minus this 2 to the power of 4. The same thing, right? Yeah, okay. And then plus 4 squared, same thing again. Okay, so if you're adding these guys, m plus n, this is 1, so that's going to be 2. This whole thing will cancel with that, and this would cancel with that. So the answer is just 2. How many 4-digit palindromes ABBA have the property that the 2-digit integer AB and the 2-digit integer BA are both prime numbers? Well, the first thing I think we need to do is list all the prime numbers that are 2-digit. And let's see if I remember 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Okay, so now how many are these? 21. Now we have to make palindromes. So we basically want a situation where we have 2-digit number and then a 2-digit number. But it's of the form A, B, and then BA. Okay, let's see. Let's start with 11. Can we make one with 11? Yeah. So that's fine. 13, this would have to be 31. Is 31 a prime? It is. All right. And then I guess, hold on. Let me not circle the 31. I'll just circle the 13 because I'm starting. I want to just circle the ones that I'm starting with. 17, the next one, you would need 71, and that is a prime. 19 doesn't work because 91 is not a prime. So that one will not work, you see? And then these ones will not work because 32 and 92 are not primes because those are even numbers. 31, okay, 31 will work. 37, yes, because 73 is a prime. These ones won't work because when you flip them, reverse them, they become even numbers. 14, 34, and 74 are even numbers, and even numbers are not primes except 2. 53, let's see, that would be 35 and 95. Those will not work because those are not primes. These are not going to be primes when you flip them. 71 is 17. 73 is 37. 79, yeah, 79, 97. Okay, these two won't, and then 97 is 79, which is a prime. Okay, so if I've done this correctly, these are the ones. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 will be able to be made, 9 palindromes with the conditions stated in the question. Adia writes a list in increasing order of the integers between 1 and 100, inclusive. That cannot be written as the product of two consecutive positive integers. What is the 40th integer in her list? All right, so we want to write all these guys out, 1, 2, 3, 4, like that. But we don't want numbers that could be written as the product of two consecutive positive integers. Okay. So let me just, and we want the 40th guy. We want the 40th number. Okay, so let me write out, I'm not sure entirely how many I will have to eliminate, but let me just write out, I don't know, the first 50 should be sufficient. Okay, so now let's think about what numbers are going to be removed from this list. And those are numbers that can be the product of two consecutive positive integers. So for example, 1 times 2 are two consecutive positive integers. So their product, which is 2, cannot be in this list. So we got to take out this guy. And then similarly, 2 times 3 is the next one. That's 6. So 6 has to be taken out. And so on. 3 times 4, which is 12. 12 has to be taken out. 4 times 5, which is 20. That has to be taken out. 5 times 6 is 30. So that has to be taken out. 6 times 7 is 42. And that's over here. And then 7 times 8 is 56. And 56, I didn't even include that. But let's see if I can get to 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. And I have. So the 40th integer in this list is 46. And 46 is obtained by removing these numbers from the list. And those numbers are numbers that can be written as the product of two consecutive positive integers. For how many ordered pairs of positive integers AB is 1 less than A plus B less than 22? Let's make a table and let's see what we get. Number of pairs. All right, so we are a positive integer. So the smallest one, let's start with the smallest one, is 1. So if A is 1, and we want to make sure that that is true, then B can be 1, 2, all the way till 20, I believe. And that means there's going to be 20 pairs. Okay, I think we just have to keep doing this. If B is, if A is 2, then B can be 1, 2, all the way up till 19, and that's going to give me 19 pairs. And then A is 3, you get 1, 2, all the way up to 18, 18 pairs. And I think you guys get the point. If I go all the way down to 19, it'll be 1 and 2 for B. And if I go to 20, the only value is 1. So that will be, this is 2 and this is 1. So to get the total number of pairs, I'm just basically adding up those guys, which I believe is like 1 plus 2 all the way till 19 plus 20. And you guys know how to do that, right? 20 times 21 over 2. And that's 210. 210 pairs that satisfy that inequality. Shelly-Ann normally runs along the Laurel Trail at a constant speed of 8 meters per second. One day, 1/3 of the trail is covered in mud, through which Shelly-Ann can only run 1/4 of her normal speed, and it takes her 12 seconds to run the entire length of the trail. How long is the trail? Well, speed is equal to distance over time, and time is equal to distance over speed. And her speed is 8 meters per second. Now, for the first part, let's see here, 1/3 of the trail. So the trail, let's just say, has d in terms of its distance. So 1/3 of that would be d over 3, and that corresponds to only a quarter of her speed. So if this normal speed is 8, a quarter of that is 2. So the t, this formula, therefore would be d over s, so that's d over 3 over 2, and that's d over 6. And then the next part of her, run would be the other 2/3, so 2d over 3, and that one she can run at the normal speed of 8. So that time calculation is, again, d over s, which in this case is 2d over 3 over 8, and I believe that's 2d over 24, or d over 12. And then these two d's, when you add them, d over 6 plus d over 12, actually they're not d's, sorry about that, they're times. These two times is what I should have said. Those two times, when added, equal the total time. And the total time is 12 seconds. So that's the equation. So then we will solve that. So that'd be 3d over 12 is 12. So 3d is 144. And therefore d would be 48. So 48 meters is the answer to this question. Determine the value of a for which 5 to the power of a plus 5 to the power of a plus 1 is root of 4,500. 5 to the power of a plus 5 to the power of a plus 1 is, what is that? Let's see here, 45 times 100, which is 5 times 9 times 100, right? So if you take the square root, it'll be 3 times 10 times root 5, so 30 root 5, I believe. 30 root 5. Okay. And then this is 5 to the power of a, and we can break this up into 5 to the power of a times 5 to the power of 1, 30 root 5. And then this would be just 5 to the power of a plus 5 to the power of a. And then this would be 6 5 to the power of a is 30 root 5. And then I can divide through by the 6, so 5 to the power of a is root 5. And root 5 is the same as 5 to the half. And therefore, wait, hold on one second, sorry. 30 divided by 6 is 5, so I should have had a 5 in there. So that's 5 times root 5. So that's basically going to be 5, this is 1, right? So 1 plus a half, 3 over 2. So therefore, a is equal to 3 over 2. Ezekiel has a rectangular piece of paper with an area of 40. The width of the paper is more than twice the height. He folds the bottom left and the top right corners at 45 degrees and creates a parallelogram with an area of 24. What is the perimeter of the original rectangle? Let's do some labeling here. Let's call this X. Let's see here. From there to there, I will call B. So therefore, from there to there is B. And then the whole distance I will call Y. And therefore, this part will be Y minus B. And that's Y minus B. Okay. And then, what do we know here? Anything? We know that X times Y is 40. The area. Anything else? Let's see here. Oh, area of 24 of the parallelogram. Okay. So, all right. I think I can figure this out. So, those two are triangles. So, 1/2 base times height would be Y minus B times X for that first triangle, plus the parallelogram, which they told me is 24, plus 1/2 base times height, Y minus B times X. And that total is 40, right? Yeah. So this basically just becomes Y minus B times X is equal to 16. And let's see, what do we know here? This is important. This one, the 45 degrees. If that's 45, well, this is 90, right? This is a right angle. If this is 45, then that's 45. So that means this is an isosceles triangle. So that means X is equal to Y minus B. So I can plug that there. Therefore, this is x times x is 16. So therefore, x is 4. And if x is 4, I can plug that there. 4 times y is 40. So y is 10. And therefore, the perimeter of the original would be 2x plus 2y, which is basically 2 times 4 plus 2 times 10, and that is 28. So 28 is the answer to this question. What is the value of? All right, well, I could probably do this with a calculator, but these numbers look very close together. So what I'm going to do is I'm going to allow one of them to be a, and therefore that is a squared. And then this is really a minus 1, I believe. And then multiplied by this, which is a plus 1. So let's see here, a squared. So this will be a squared minus 1. And then therefore this will be just 1. Okay, so that worked out nicely. Determine the value of. So we have to use log rules. Log rules usually people do not remember. And this one, I think, is one of those log rules that people don't remember. It's called the change of base rule. And the change of base rule is as follows. If you have the log of b to the base a, it is the equivalent of the log of b to any base, let's just say c, to the log of a to that same base. So I'm going to apply that here. So log of 4 to the base 2 is the same as the log of 4 to the base c over the log of 2 to the base c. And then multiplying that by the log of 6 to the base 4, log of 6 to the base c over the log of 4 to the base c. And then same kind of story, log of 8 to the base c times the log of 6 to the base c. Okay, so as you can see now, we can cancel. That cancels with that, that cancels with that. So the only thing we're left with is log of 8 to the base c over the log of 2 to the base c. Now the log of 8, that 8 can be changed to 2 to the power 3. And then using log rules, you put the 3 out front. So you get this kind of scenario. And then finally, these two guys cancel, and the only thing we're left with is just 3. So 3 is the value of this whole expression. X, y, and z satisfy x over 5 equals 6 over y equals z over 2. What is the largest possible value of x plus y plus z? All right, so I'm going to do a little bit of experimenting here. If x equals 5, and y equals 6 and z equals 2, those will all be equal. So x plus y plus z would be 13. But they want the largest possible. Okay, let me just keep going here. What if I made y equal to 3? That would allow me to make these numbers a little bit bigger. X would be 10, z would be 4. And then now x plus y plus z is 17. I think I can make it a little bit bigger. What if I let y equal 1? Then x could be 30 and z could be 12, and then therefore this would be 43. And I think that's about as big as I can go, because they have to be integers. I can't make y less than 1. I can make it negative, but then they want the largest possible value of that. Negatives would obviously make it a smaller value. So 43 is the answer. Suppose that g, which is 10 to the power of 100, g is known as a googol. How many times does the digit 9 occur in the integer equal to g minus 1009 squared? G minus 1009 squared. Okay, well, g is 10 to the power of 100, and then we have 1009 is 1018,081. Okay. So let's try to figure this out. Let's subtract 1 from this, and then if I do that, I have to add 1 here. So this will be a whole bunch of 9s, right? 9, 9, 9, dot, dot, dot. And I believe it's going to be 100 9s. And then this one, and that's just a number. That's just 101808. Hold on, what did I do here? 101808 0, right? Because it's a negative number. Okay. And then now, that shouldn't be a problem now, because this whole bunch of 9s eventually will be untouched, except for the last 7, right? Because this is 7 digits, so only those 7 digits. So let me put those 7 9s separately like that. And then this 101808. 10180. Okay, so of those 100, these guys, 93 of those 9s are untouched, and then these 7 of them are going to actually be affected by that guy. So we're going to have 99, all those 9s untouched, the 93. And then this number, the 999 minus the 10180 becomes 8981919. So now that's the final number. So how many 9s are in here? Well, there's 93, 94, 95, 96. So 96 9s are in that number that they are calling G minus 1009 squared. Suppose that f at x is x to the power of 4 minus x cubed minus 1, and g at x is x to the power of 8 minus x to the power of 6 minus 2x to the power of 4 plus 1 if g at x is equal to f at x times g at x, h at x. What is the polynomial h at x? Okay, so I guess we are looking at g at x over f at x. That is h at x. And I have to figure out what that is. So h at x would be, what's g at x here? X to the power of 8 minus x to the power of 6 plus 2x 4 plus 1. And f at x is x4 minus x3 minus 1. Okay, so I got to do this long division type of thing. So here we go. And let's see if I even remember how to do it. It's been a long time since I've done this. All right. Okay, here we go. Let's see what we get. So how many times is x to the power of 4 going to x to the power of 8? I believe x to the power of 4 times. So then I'll multiply x to the power of 4 times this is x to the power of 8. X to the power of 4 times that would be, hold on. X to the power of 7, yeah. And then x to the power of 4 times this would be just x to the power of 4, I believe. Okay, so now subtract these guys. So these two will go, and you'll have minus x to the power of 6 plus x to the power of 7 minus that, so they'll be minus 2 minus 1, so it'll be minus 2 plus 1. So that would be plus, or just 1 negative x to the 4 and then plus 1. I believe that's correct. X to the power of 7 minus x to the power of 6 minus, yeah. Okay, so now we got to figure out how many times does this go into here. Let's see here. It'll go x to the power of 3 times. So let's multiply that. X to the power of 3 times x to the power of 4 gives me x to the power of 7. And then multiply that by x to the power of 3 minus x to the power of 6. And then minus x to the power of 3. Okay, I think that's correct. Minus, let's see here. X to the power of 7 minus x to the, yeah. Okay, so now let's subtract these. And when you do, you get minus x to the power of 4 plus x to the power of 3 plus 1. Okay. Now let's see how many times this goes. This is 1, so this will be x to the power of 4 minus x to the power of 3 minus 1, and this is 0. So that is the polynomial. So therefore, h at x is equal to x to the power of 4 plus x to the power of 3 minus 1. In the diagram, pentagon ABCDE is symmetrical about altitude CF. Also, AE is 200, CF is 80 root 3, and ABC is 150, and BCD is 120. Determine the vertical distance AE between AE and BD. Between AE and BD. Okay. So I'm assuming that is this just from here to here. That. And I'll just call that, I don't know, H. H sounds pretty good to me. Okay, so there's going to be a lot of angles in here. I'm going to have to draw a few lines. So I think just that one line should be sufficient. And then to avoid making this diagram messy, I'm going to probably draw a little bit of a diagram here. And then I'll be able to explain how the angles work, and then I'll fill it in over here. So let's talk about the angles. This is a right angle here, this is a right angle here, like that. And then let's see here, ABC is 150. ABC is 150. Okay. And then BCD is 120. So BCD is 120, it's symmetric, so that means this is 60. And then since that's a right angle, that's 30. And this is a right angle. And since ABC is 150, this little guy in there would be 150 minus 90 minus 30, which would be 30. And then for this would be 60. So you got two 30, 60, 90 triangles. And we all know the ratio of the 30, 60, 90 triangle, right? I mean, I hope by now. The ratio of the sides, 1, 2, and root 3. The ratio of the sides of a 30, 60, 90 triangle. So let's do some labeling now. So the labeling, whatever letters you want to use, I'll call this Y. We've already called that H. There's AE is 200. So from here to here would be 100. And I'll call this distance X. And then therefore this little guy would be 100 minus X. Correct. Okay. And then from here to here is also H, since it's the same thing from there to there. And then this is X. All right, I think I've got pretty decent comparison here. So now let's use this 30, 60, 90 triangle stuff. So that means that 100 minus X over H is the same as 1 over root 3 using those ratios of the sides. So that means that H is equal to root 3 times 100 minus X. And then in this triangle up top, that one we can deduce that X over Y is the same as root 3 over 1. So therefore, X over root 3 is equal to Y. And then we know that CF, all the way from top to bottom, this is C, this is F, so all the way from top to bottom is 80 root 3. And in my diagram, it's Y plus H. So Y is X over root 3 from here, and H is this guy, root 3 times 100 minus X. Okay, and I think that will help me figure out X, and then finally I can figure out H, because H is what they wanted. Well, what they wanted is that distance that I've labeled as H. And I can use this formula right here. Okay. So let me multiply through, well, what should I do here? Multiply through by 3 or? Sure. If I multiply through by root 3, then I'll get 80 times 3 and X, and then this will be 3 times 100 minus X. So this is 240 is equal to X plus 300 minus 3X. So this is 60 is equal to 2X, and therefore X is equal to 30. X is equal to 30, but I want H, so that means root 3 times 100 minus 30 is H, and therefore H is 70 root 3. And that is the answer to the question. The height of cylinder A is equal to its diameter. The height and diameter of cylinder B are each twice those of cylinder A. The height of cylinder C is equal to its diameter. The volume of cylinder C is the sum of the volumes of cylinders A and B. What is the ratio of the diameter of cylinder C to the diameter of cylinder A? So we have cylinder A. So here we go. Something like this, right? And so we've got a height, which I will call D, and the height is 2 times the radius. Well, D is equal to 2 times the radius. Diameter is 2 times the radius. And that takes care of cylinder A. Cylinder B is basically twice. So that one I'll call a big H, and let's say it's twice the diameter, twice the diameter of cylinder A, and that basically means that it's 2 times 2r, which is 4r. Right. And now we've got cylinder C. And cylinder C, what's the story here? The height is equal to its diameter. Okay. So this one I'll just call H2 and D2. And that's basically 2r2, where H2, D2, and R2 are the measurements of cylinder C. I don't know what they are, so I'll just label them like that. Okay, so now we are told that the volume of cylinder C is equal to the volume of cylinder A plus the volume of cylinder B. All right? So the volume is pi r squared times height is the volume of a cylinder. So let's plug this all in. This would be pi r2 squared times H2, and this is going to be pi r squared times height, and this is going to be pi r squared times height. Yeah. Okay, let me just make sure I do this carefully here. So first let's get rid of all the pi's. That way we don't need them. So r2 squared, let me leave that in there for now. H2 is the same as 2r2. So 2r2. So let me see if I did that right. That's going to be, yeah. So that would be 2r2 to the power 3. Okay. Now we have this guy here. So this one is just r squared, and then h is 2r, so that would be times 2r. And then this one is big R squared, but big R squared was the same as, it was twice, right? So it's 2r. Yeah, if you go back to cylinder B, the height and diameter are twice that of cylinder A, so that means the radius is also twice. So that means that r is actually the same as 2r, 2 small r, and the height was 4r. So that's that. So this will be 2r cubed plus, this is going to be 4r squared times 4r, so it'll be 16r cubed. So this will be 18r cubed is 2r2 cubed. So r2 cubed is the same as 9r cubed. And therefore, r2 over r cubed is 9 over 1. And if you take the cube root of both sides, you get r2 over r is equal to the cube root of 9 over 1. And that is what they wanted. They wanted the ratio of the diameter of cylinder C. Oh, I did radius. Oh, no. They want the ratio of the diameter of cylinder C to the diameter of cylinder A. Okay, I did the radius, but the diameter would just be 2, so it wouldn't change. Well, that's interesting, actually. So it would be D2 over D. Yeah, it's the same thing. I actually calculated for the radius, but they wanted the diameter. But even if you did the diameter, the ratio would still be the same, which is the cube root of 9 over 1. Suppose that f at x is equal to a times x minus b times x minus c is a quadratic function where a, b, and c are distinct positive integers less than 10. For each choice a, b, and c, the function f at x has a minimum value for what is the minimum of these minimum values. Oh boy. All right, so we've got this quadratic function, and I have no idea what it looks like, but let me just make a guess. I'm not sure, but let me just see. It's say something like this, right? This is x and this is y, and it's been written in a way that we can easily figure out the roots, right? Because if this was set to 0, and I asked you what are the roots, you can easily tell me the roots are x equals b and x equals c. So that means that let's just say this guy is b and this guy is c. So in the very middle of it, which would be b plus c over 2, that would basically be the vertex where that would give you the minimum value of the function. Yeah. So that makes me think that the min value of f at x happens when x is equal to b plus c over 2. Okay, I think that is a pretty good start. Okay, so now we've got to figure out what is the value of f at x when you have x equal to b plus c over 2. So we got to plug that into this guy. So let's do that. So we have a b plus c over 2 minus b, and then b plus c over 2 minus c. And we crunch out all that. I'll let you guys do that. It'll be minus a b minus c squared over 4. So we basically want to minimize this. That's our goal. We want to minimize this. And I guess we just have to plug in numbers. That we are not told any... Are we told anything? The only thing we're told is that they're distinct, A, B, and C, and that they're less than 10. Okay? So let's see. If does that help me at all? That they're distinct, that they're all different integers, and they're all less than... Okay, if they're less than 10, then that means that we have a very limited amount of choices. They can be either anything, only 1 through 10, so that makes it a little bit easier. Okay, so let's see how we can minimize this. Let me think about this. So if I want that expression, this expression to be as low as possible, minimize it, right? Then I've got to choose the largest A and the largest B. And then C's got to be as small as possible. Okay, so let's see. C's got to be as small as possible, so that's a 1. And the largest A, I'll choose 9, and the largest B, I'll choose 8. And then let's see what happens. If I plug those numbers in, I will get 9 minus 9 times 8 minus 1 squared over 4. And that, well, what is that? Minus 9 times 7 squared, which is 49 over 4. Which is 441 over 4, which is about minus 110.25 or something. I think so. 110.25. Yeah. Okay, let's see if I can go even lower. C I'll keep at 1. This time I'll make the B equal to 9 and the A equal to 8. And let's see what I get. So this time it'll be minus 8 times 9 minus 1 squared over 4. And that is going to be minus 512 over 4, and that is minus 128. So that's even lower. So that is the one that's the lowest. And I think you can fiddle around with these numbers, but I think that is the lowest I can get by choosing 3 distinct values from those 9 digits. The integers from 1 to k are concatenated to form the integer n equals 1, 2, 3, and so on. Determine the smallest integer value of k greater than 2019 such that n is divisible by 9. Oh boy. Interesting. So we're going to use divisibility rules. Amazing how many i's there are. 1, 2, 3, 4, 5. Divisibility. 5 i's. And in particular, divisibility rule for 9. And that rule, if I remember, says that a number is divisible by 9 if the sum of the digits are divisible by 9. Are divisible by 9. Okay, so we got to figure out the sum of the digits. Oh, that's very, very long because this is going up to at least 2019, so painfully long, and that's way too time consuming, so there's got to be a better way. There's got to be a better way of doing this. Let me start off with a simple example. Let's say we have 1, 2, 3, 4, 5, 6, 7, ... all the way to k, right? Now, what does this mean? It means this 1 times some power of 10. I don't know what that power is, so I'm going to call it A1. Then it's 2 times some power of A again. It's 1 less power, but I'll just write it A2. And then, because I don't know what A1 is. And then so on. 3 times 10 to the power of 3, and you guys get the point. And then eventually you'll get to the k minus 1, because this number is k minus 1 right before it. So it'll be k minus 1 times some, it'll be just 10. And then the last one is k times 10 to the power of 0. That's pretty much the way you would write it out. Now we want to do some not extremely fancy algebra, but a little bit of fancy algebra. Is that from each of these 10s, I'm going to subtract 1. So minus 1 like that. And then 2, 10 to the power of A2, minus 1 like that. Plus 3 times 10 to the power of A3, minus 1, and then so on. You guys get the point. And eventually k minus 1 times 10 to the power of 1 minus 1. And then I think I'll stop there because the last one, that's 10 to the power of 0 is just 1. So if I subtract 1 from it, it'll be negative 1. I'll just leave it at that. So this looks to me like 10 to the power of something minus 1 will be a whole bunch of 9s. Right? Whatever the A1 is. If A1 is 5, if it's 20, whatever it is. So it'll be a whole bunch of 9s. So I'll just put 9s in there. Yeah. And similarly with this guy, it'll be a whole bunch of 9s. This will be a bunch of 9s. And then ... all the way till k minus 1. And that is 9. So we can factor out a 9. And everything will be able to be factored. Because there's a 9 from here, 9 from here, 9 from here, 9 from here. So that means that m is divisible by 9. We've shown it. So that's the goal of that fancy algebra there, to show that m is divisible by 9. But we want n to be divisible by 9. This guy. So what we can do is we can subtract them. We can say n minus m. If that is divisible by 9, then n is divisible by 9. Because we already proved that m is divisible by 9. So n minus m, if we do this carefully, we will get let's see here, 1 times 10a minus 10a plus 1. And then we'll have 2 times 10a2 minus 10a2 plus 1. And then 3 times 10a3 minus 10a3 plus 1 plus k minus 1 times 10 minus 10 plus 1. And then finally, there's a k left over there. So then this is really just 1 plus 2 plus 3 all the way till k minus 1 plus k. So this, with that formula, is k plus 1 times k all over 2. So that's n minus m. So if we can show that this guy is divisible by 9, then since we've already proved that that's divisible by 9, we will also prove that that is divisible by 9. And that is the goal, to show that n is divisible by 9. So now what we have to do is take values of k that are greater than 2019 and plug them into here and see which one of them is divisible by 9. So let's make a little table here. K, is it divisible by 9, yes or no? And let's see for values greater than 2019. So we got 2020. If we plug that into here, you'll see it's not divisible by 9. I'll let you guys do that. 2021, no. 2022, no. 2023, no. And 2024, the answer is yes. So that's the minimum, because they wanted minimum, right? Yeah. Let's see here. What is the smallest? Yeah, they wanted the smallest. So we can stop at 2024. We don't need to go further, because that's the smallest number that makes this expression divisible by 9, and therefore that proves that n would be divisible by 9. The real numbers x1, x2, x3 up till xn are the consecutive terms of an arithmetic sequence. If that big long expression equals 1957, what is the value of n? Okay, let's plug this in. So this would be a, this would be a plus d, this will be a plus 2d, and so on, right? And the last one would be a plus n minus 1d. So let's plug them in. So this would be a plus d, and x1 plus x3 would be 2a plus 2d. And then this one would be a plus 2d, and 2a plus 4d. Right? And you guys can verify that. I'm just doing it quickly. A plus 3d, this guy here, and that's going to be 2a plus 6d. And then eventually you get all the way to the end, this guy, and then this one. The very last one would be a plus n minus 2d, and the bottom would be 2a plus 2 times n minus 2d. And all of that equals 1957. Well, you'll see, all of these are a half. All of them. So, we have to figure out how many of these are there. Well, it starts at what it ends here at xn, and this is x3, so my guess is there's an n minus 2 of those guys. There's n minus 2 terms. So it's n minus 2 times a half is equal to 1957. And therefore, n minus 2 would be 1957 times 2. And therefore, n calculates out to be 3916. Suppose that f at 1 at x is equal to 1 over 2 minus x. For each positive integer n greater than or equal to 2, define f at x to the n is equal to f at 1 at f at x to the n minus 1, however you want to say that, for all real numbers x in the domain f at 1 at f at n minus 1 at x. The value of f at 4 2019 or f at the value of f 2019 at 4, I'm trying to think how to pronounce it, can be written as a over b. What is AB? All right, so here we go. Let's not get too intimidated by this. Let's just tackle it. That's 1 over 2 minus x, right? So then let's just figure out what would be f at 2 at x. And we're just going to use this recursive formula again and again. Hopefully it won't be too bad. So it'll be f at 1 times f at 2. Let me just hold on. F at 1 at f at 1 at x. Yeah. So that'd be f at 1 at 1 over 2 minus x. So then we'd substitute that into this guy. So it'd be 1 over 2 minus 1 over 2 minus x. Is that right? 1 over 2, yeah. And then when you do this math, I'll let you guys do it. I can do the first one. 2 minus x. So this would be 2. This would be over 1. So 2 minus x times 2 minus x. So it would be 4 minus 2x minus 1 over 2 minus x. So that would be 2 minus x over 3 minus 2x. Yeah. Okay. Let me just make sure I did that correctly. All right, so now let's move on to the next one. Would be f at 3 at x. And my hope is that eventually we see a pattern. And then, because obviously we want, there's no way we're going to be able to keep on going till f at 2019. F 2019 would take forever. So we're going to do a few, and then we'll see if there's a pattern. F at 3 at x. So here we go. That would be f at 1 at f at 2 at x. So that would be f at 1. So it's going to be 2 minus x over 3 minus 2x. So that's going to be 1 over 2 minus x over 3 minus 2x, like that. Yeah, and then when you crunch this out, it'll be 3 minus 2x over 4 minus 3x. Okay, some of you might be able to see a pattern, some of you won't, but that's okay. I'll do a few more. So f at 4 at x, f at 1, f at 3 at x. So this would be f at 1 of 3 minus 2x times 4 minus 3x. So that would be 1 over 2 minus 3 minus 2x over 4 minus 3x. And when you crunch this out, it would be 4 minus 3x over 5 minus 4x. Okay, some of you are seeing a pattern here. I'll do one more. F at 5. On this one, I'll just write out the answer. You guys can do the math. It's going to be the same thing. That it would be f at 1 at f4 at x. So f1 at f4 at x. And that is 4 minus 3x over 5 minus 4x. So this would be 1 over 2 minus 4 minus 3x over 5 minus 4x. And therefore that would be, when you calculate that, 5 minus 4x. Oops, sorry. 5 minus 4x over 6 minus 5x. Okay, so I think by now should be able to get a little bit of a pattern. F at 2 is this guy. F at 3 is this. F at 4 was this. And F at 5 was this. So I conclude that F at n, or Fn I should say, the correct way I think to pronounce it is Fn at x would be, let's see if I can figure this out here. It would be n minus 1 x over n plus 1 minus nx. I think that is correct. So therefore, F 2019 at x would be 2019 minus 2018 x over 2020 minus 2019 x. And therefore, F 2019 at 4 would be 2019 minus 2018 times 4 all over 2020 minus 2019 at 4. and therefore this will be 2019 minus 8072 over 2020 minus 8076. The numbers P, Q, R, and T satisfy P less than Q less than R less than T when these numbers are paired. Each pair has a different sum, and the four largest sums are 19, 22, 25, and 28. What is the sum of the possible values of P? So the pairs are P plus Q, P plus R, P plus T, and then Q plus R, Q plus T, and then R plus T. And that could be, you'd think that there's only one way of doing it, but there's a couple. The first way is just to chronologically put them, so 28, 25, 22, and 19. But what's interesting is that they could be flipped also. It could be 28, 25, but this would be 19 and that could be 22. That is possible. So that's why we got two different scenarios. So then you just kind of solve. So if I look at, it doesn't really matter which way you want to do this, but let's say if I look at this scenario, that means that if I do that, Q would be 22 minus R, and then T would be 28 minus R, and therefore I can plug that into this guy. 22 minus R plus 28 minus R is 25. So that means 2R is equal to 25. So that means R is 12.5. And then if R is 12.5, then that means T would be 15.5, and then P would be 3.5. Okay, and then do the same kind of thing with these numbers. That would give you again Q is equal to 19 minus R, T is equal to 28 minus R, and then Q plus T is 25, so that means 19 minus R plus 28 minus R is 25. So therefore we've got 22 is equal to R, and 2R I should say, and therefore R is equal to 11. And if R is equal to 11, then Q is equal to we're dealing with this guy here, so Q would be 8, and then T would be 17, and then P would be 5. So these are the two values of P, and they want the sum, so it would be 5 plus 3.5, which is 8.5. Suppose that alpha and beta are the two positive roots of that equation. Determine the value of alpha times beta. Okay, let's use whatever we can. I'm assuming we're going to have to use log rules. So that is the initial one. And what kind of, I can take the log, let me put 1 on both sides here, like that. There we go. And let's take the log of both sides now. So we got x squared and the log of this whole guy, 13 times x log x to the base 13. Okay, using log rules, that becomes log of x. And I didn't write a base. I'm going to write base 13. Squeeze that in there. Base 13. Base 13. Yeah. Okay, so then using log rules here, I got to split this up into root 13 plus the log of this x log x to the base 13. Okay, so then let's see here. Well, this one, I don't know what I can do there, so let's leave that alone. This one becomes the log, that's 13 to the half, so I put the half out front like that. And then this one, put this out front using log rules. And there we go. So it kind of looks pretty decent. And then at this point, this log x13 seems to appear everywhere. So let's just call that a. So this will be 2a. And this is just 1, so that's a half. And this is a squared. So that means I've got a quadratic a squared minus 2a plus a half equals 0. And then I got to use a quadratic formula. A is equal to 2 plus or minus 2 squared minus 4 times a half all over 2. And that's going to give me 2 plus or minus root 2 over 2. So let's keep in mind that's a. So that means that the log of x to the base 13 is equal to 2 plus or minus root 2 over 2. So that means 13 to the power of 2 plus root 2 over 2 is x, or 13 to the power of 2 minus root 2 over 2 is x. And what do they want? They want the product, right? So we got to multiply these guys. So 13, 2 plus root 2 over 2 times 13 to the power of 2 minus root 2 over 2. Exponents are added, so that's going to be 13, 4 over 2, 13 squared, so which is 169. Yep, that's it. In the diagram, ABCD is a square. Point F is on AB, and BF is 2AF. Point E is on AD with angle FEC equal to angle BCE. If angle ECD is between 0 and 45, what is the value of tan of the angle ECD? Let's label as much as we can. Let's see here. First of all, AF is 2AF is equal to BF, okay? So if AF, for example, was 1, then that means BF would be 2. So we basically just kind of said that the side length is 3. ED, they don't give me, so I'm going to have to call that x. So AE would be 3 minus x. And then we need to figure out some angles here. Well, ECD is the main angle, so I'm just going to call that theta. So then, therefore, this angle in here would be 90 minus theta. So ECD angle I've called theta. Let me just put that there. This is 90 degrees. So this angle in there is also 90 minus theta. And anything else that we know? Let me see here. Anything else that they told me? Oh, this is important. FEC is the same as BCE. So that means this is 90 minus theta. Okay, that was very important. So therefore, I can calculate this guy. That guy would be, well, that's angle AEF, and that's basically 180 minus that 90 minus theta minus the other 90 minus theta. And that calculates to 2 theta. So that's 2 theta. Okay, so I think that's pretty decent. That will allow me to get some relationships here, trigonometry relationships, and I'm using tan most likely. So in the triangle EDC, the tan of theta would be opposite over opposite over adjacent, right? So x over 3. And then in the triangle EAF, the tan of 2 theta would be opposite over adjacent, 3 minus x. All right, great. And then you guys know the trig identity tan 2 theta. Some of you may have forgot it, so I'll write it here. Tan 2 theta is 1 minus tan theta squared. And we're going to substitute this guy and this guy into it to figure out x. And then once I figure out x, I should be able to figure out the value of tan theta. Yeah. Okay, so let's do that. So tan 2 theta, which is 1 minus 3x, is the same as 2x over 3 all over 1 minus x over 3 all squared. Yeah. And if you simplify this, simplifying, you will get down to 5x minus 3 times x minus 3 is 0. And that will give you either x is 3 or x is 3 over 5. Well, x cannot be 3 because the whole side length was 3, so x is 3 over 5. So if x is 3 over 5, you just take that, tan theta, and put 3 over 5 in there. So that would be 3 over 5, invert and multiply, and you get 1 over 5. 1 over 5 is the answer to the final question.